Hey there. So, in this lesson, what we're going to do is actually show the complete process of creating a great sounding preset from sampling through the programming and adding effects. And this lesson was inspired by a preset that I recently built that's this very rich pad sound. It's got an electric piano on top and then this rich pulse width modulated analog synth sound on the bottom. So let me just load that up and you can listen to the finished preset. Okay. You can hear that this sound has two basic components to it. The first is this electric piano sound. And then the second is this analog synth sound that does a filter sweep, and of course I've set up continuous controllers so that you can tweak the filter in real time. Other things that I've added, of course, are vibrato. You hear that it's very subtle. And I also made this special effect so that you can actually sweep the pitch of the pad sound up and down by an octave when you push a special switch. So I'm going to show you how to create this sound. So the first thing that we're going to do is clear out the memory in the sampler. So I'm going to go File, New. This will give us a blank workspace. The other thing that you would want to do is make sure that your Patch Mix DSP mixer is up, and just open the default Emulator X session. So if you got the 1212, you would select this one. If you've got the 1820 hardware, you would select this one. So I'm not actually going to load one right now because I've got the mixer configured the way I want it. Go back to Emulator X, and the first thing we're going to do is sample in the electric piano sound. So this is a sound I created on another synthesizer, actually on my Nord modular keyboard. And what I'm going to do is I'm just going to sample each C key up and down the keyboard like this. Okay? And Emulator X will automatically detect each sample and create a very basic preset for me. So let me show you how that's done. What we're going to do is go File, Acquire Samples. The Acquire and Shop Samples window is where you record audio that you want to place into a preset. And the first step is to click the Record button. The Record Audio window comes up, and you'll see that the Emulator X is sampling from its main output. Now, I've got this set up so that I'm going to record from the main outputs of the eDSP card, but you can also just select the I/O inputs. So what I'm going to do is turn down the volume on the microphone and sample about 6 sounds, and then I'll be back. So click the Record button to begin. Okay, now that we've sampled our raw sounds, I'll click OK, and you'll see that Emulator X has put the audio into the record window. I can zoom in, we can see each individual sample. Now what we're going to do is we're going to have Emulator X automatically identify where our samples start and end. And we do this with the gate chop parameter over here. You'll notice there's a little T icon here, and that sets the gate threshold. You'll see as I move this up and down, it changes the level over here. And the trick is just to set the threshold so that the whole sample fits inside of that level. Okay? Then click Apply, and you'll see that Emulator X has set 6 sample regions for me. If I double click on one of these regions, I can actually play the identified region. So these all look pretty good. One thing I'm going to want to do, and you'll see I accidentally hit the lock button here. When you hit the lock button, that keeps you from moving the sample start and end points. You'll see that the sample start and sample end for this sample have been disabled. I can just unlock that. Now, what I want to do is, because I'm going to have Emulator X automatically loop these samples, I'm going to move the endpoints in for each one. And what that's going to do is make sure that the crossfade loop works correctly. So I'm just going to take the endpoint of each sample, move it in a little bit just so it's in this nice sustaining region, but it's away from the place where the amplitude falls off. So I'll just move these in. Do that for each sample. Move him in just a little bit more. Okay, so now we've got our start and end points set correctly. Of course, I could listen to these again. Yeah, so this is all going to be fine. Now, Emulator X can automatically detect the pitch of each of these samples so that we can map them properly across the keyboard. All I do is Shift select all 6 regions and click Set Keys. And what Emulator X has done is it has tried to identify the root pitch of each key. Now, it messed up a little bit. On the low sample and the high sample, it got it wrong. This is not C#2. This should actually be C1. So I'll just go in and change that. And this sample we know is C6. Alright, so now that that's done, I can automatically set names for these samples. It doesn't really matter what your sample names are, but it'll make life a lot easier if inside the sampler they have sensible names. So I'm going to, once again, select all 6 regions, click Set Names, and then we can give these a name. I'm going to call them FM EP for FM electronic piano. And then if you click this button, Emulator X will automatically append the name of the bass key to the sample name. So now you'll see that we have FM EP C1 through C6. Probably should have gone in sooner and locked down the loop or the sample start and end points so I didn't accidentally change them. So everything's okay now, and what I'm ready to do is I'm ready to export these samples to the sampler and build a basic preset. So I click Save to Sampler, and the Save Samples window is where I can define how I want my preset created and what I want done with my samples. The first option is normalization, and this is, of course, just like normalization in a digital audio application. It takes the audio and moves it to digital full scale, so basically we'll increase the volume so we have the highest signal to noise ratio. And what I want to do is select absolute in this case. There are 2 options, absolute and relative. Absolute takes the left and the right channel and normalizes them independently. Relative would take into account the relative volumes of both samples. Now, the instrument that we just sampled is completely monophonic, so it doesn't matter if I select absolute or relative, so I'm going to select absolute. The next option is an option to have Emulator X automatically loop each sample, and there's many different options here. You can turn it off if you want to. But what I want to do is I want to just loop the last third of the sample and have Emulator X crossfade it so that it's a very smooth loop. So you'll see that what we're going to do is we're going to loop about this area right here. Then there's an option for building a preset. If you unclick this button, Emulator X will just drop the samples into the sampler, but it won't assign them to a basic preset. We want to do that, so we'll click Build Preset. We'll give it a name. I'm going to call this KRC's FM Electric Piano. Placement is where you tell Emulator X what to do with each sample. If you select original key, it's actually going to put the sample on the key that was identified here, the original key setting. And then stretch tells Emulator X how you want the samples mapped up and down the keyboard in the preset. You can turn that off, and if you turn it off, we would just have 6 samples that only play on keys C1 through C6. They wouldn't play on any other keys. what we actually want to do is we want to stretch the samples so that they go up and down the keyboard. So I'm going to click stretch up and down. And then this final option controls whether you have individual voices created for each sample, or if you want to combine the voices, the samples, into a single voice called a multi-sample. And we actually want to do that in this case. I click OK, and the samples are moved into the sampler. I can now click Done here. Okay, now that we're back in the sampler, you'll see that Emulator X has automatically created a new multi-setup for me with this one preset in it. It's KRC's FM EP, just like we told it to create, and we can listen to it and hear what it sounds like. And it sounds like Emulator X did a pretty good job of setting my sample loop points. These sounds are all pretty good up and down the keyboard. So if you were just wanting to sample a sound from a synthesizer, you're basically done at this point. But there's a lot more that we want to do in creating our rich pad sound. Now, some things to point out here. In the multi-setup, you'll see that I'm transmitting on MIDI channel 1. The little red light lights up to show that we're receiving MIDI data on that channel. Now, we can go in and examine the preset. So we open the presets tree, and you'll see there's my preset. We can open the samples tree, and you'll see here are the 6 samples that were created for me. We can look at them if you want to, and you can see there's the sample loop that was created. And they're all pretty good. Okay, let's try to turn this preset into something that is a little more usable. There's a couple problems with it so far. The first thing you'll notice is that there's just not a lot dynamically going on in this sound. No matter how hard I strike the key, the only thing that changes is the volume. The brightness of the sample doesn't really change at all. And in fact, there's not a lot of dynamic range. If I hit hard, it's kind of loud. If I hit soft, it's kind of soft. We want to change those things. So to go in and edit the sample, we go to the preset tree, and we can open up KRC's FM EP. And let me just show you a couple things. Here's the voices and zones window. This actually shows me the samples that are mapped across the keyboard, and Emulator X did exactly what we asked, and it created a single multi-sample. So this basically represents one voice, and inside it there are all these individual samples. If I click on one of the samples, double-click it, that opens the sample edit window. I can inspect my samples. I can go back to voices and zones. And this is where we select voices for editing. Now what we want to do in this case is we want to edit every sample that's in the multi-sample. So I just click here. You see that the red highlight indicates this is the voice we're going to be working on. And now I can click voice processing, and this takes me to the voice processing window. And the voice processing window is where all of the synthesis parameters are. The first thing that we'll take a look at is this whole issue of volume. I want this to be a lot more responsive. Now, how you make a sample louder based on how hard you strike a key is done with patch chords. So the patch chords section is over here, and you'll see that the default preset assigns this modulator called velocity less than, which is like velocity scale, to amp volume. So that's the volume of each sample that plays. If I were to set this to 0, actually I'll just click in here, type 0, what'll happen is that no matter how hard I strike a key, this voice will always play with the same volume. I want the opposite kind of behavior. I actually want a higher dynamic range, so what I do is I set the modulation amount to be higher. So I'm going to set it up here at like 100, and what you'll see is that if I strike very softly, the voice is very soft, and if I strike very hard, the voice is much louder. Now I ultimately want something that's kind of in between, so I'm going to select about 50%. You can also double click and just type it in. Okay, so now we've got some good amplitude response. But a real electric piano, when you really spank the keys, you'll get this really nice tine sound. And that's actually in our sample. You can hear at the beginning of the sample, there's this kind of brighter sound. And we only want that to come through when we really strike the keys. And so how we can simulate this is with filtering. The filter window up here is where you can select any of the 50 different filters, 54 actually, that are in Emulator X. And let me just show you some examples. Let's select the 6-pole low-pass filter first off. So as I play, I can adjust the filter cutoff and also the resonance. And you hear this is kind of the classic, really aggressive filter sweep kind of sound. And so you'll see what's happening here is the little graph changes as I adjust these two wheels. This is filter cutoff frequency, and this is filter resonance. And what this diagram means is that low frequencies will pass through and higher frequencies will be rolled off. And you can hear, as we move the filter up, see, there's just the bass electric piano sound, and there's that tine sound starting to come through. Now for this patch we don't want quite such a cartoonish response, so I'm going to go in and select a more subtle filter. I'll select the 4-pole low-pass filter. The 4-pole low-pass will give us about what we want. So you can see that if it were set here, that would be good, and then with velocity, I want to open the filter up. So how do we do that with the patch chords? Well, there's a patch chord that's already set up for this, because this is a fairly common type of operation, and it's this one right here. It's velocity scale to filter frequency. So let's talk about the patch chords a little bit more. Patch chords take a modulation source, and you see that there's a ton of modulation sources, and it connects the modulation source to a modulation destination, and again there's a ton of modulation destinations. In this case we're going to connect this velocity modulator to the filter frequency. Now the velocity scale modulator works in the following way. MIDI velocities go from 0 to 127, so there's basically 127 volume levels. What happens with the velocity scale parameter is the more velocity that you strike a key with, the less it subtracts from its destination. So when you hit the key very softly, it subtracts a whole lot, and when you hit the key hard, it subtracts very little. This seems a little counterintuitive, but it's a great way to modulate things like amp volume and the filter frequency. Let's just kind of show by example. Let's go and set this parameter to be 100%, velocity scale to filter frequency. And you'll notice that now as I strike a key very softly, the sound is very much rolled off. The high frequencies don't come through, and then when I really hit the key hard, I get that tine sound. And that's what we want. That's like how an electric piano actually works. Okay, so that's maybe a little bit extreme, so we're going to set this to maybe about 50% or so. Okay, that sounds pretty good. So let's leave that set where it is. Now another thing that becomes a problem once we do this is that in the very high keys, you'll see that we never quite get the tine sound coming all the way through. This is because the filter is always closed way down. There are much more higher frequencies in these high samples, and so we can make an adjustment for that. There's a modulator called key tilde, and what key tilde is oops, let's try that again. Key tilde. Key tilde is a modulator that is basically 0 at middle C, and then it creates higher values for really high pitches and negative values for really low pitches. And what we want to do is we want to just adjust this. See, as I move this up, we're letting more of the frequencies through on the higher keys. If we set it negative, you'll see that the high keys are always very damped. That's about the right setting. Well, it's a little high. There, that's about the right behavior. Sounds pretty good. We might want to go and save our work. Okay, so the next thing that I'm going to do with this particular voice is set up kind of an effect modulation. A lot of electric pianos are played with an effect called tremolo, and tremolo is similar to vibrato, but it's when the loudness of a sound changes over time. And so what I'm going to do is I'm going to use one of the LFOs. And LFO is a low frequency oscillator, and that's this section right here. There are 2 LFOs per voice. And the LFO makes a control signal that goes up and down in various ways. There are many different shapes that we can select. We'll actually use a triangle wave. And what we want to do is we want to map this triangle wave to the volume of the sample. So the way that we can do that is by selecting LFO1 tilde, and LFO1 tilde both adds and subtracts loudness. So it's going the wave is going to go from negative to positive as it goes through its cycle, and we'll connect that LFO to amp volume, and then when we give it a chord amount, you'll see that things actually change. So you hear that? Now, as we play the sample, you get this wah, 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 wah kind of sound. That's tremolo. Now, this actually sounds pretty good. It's relatively realistic. I want to slow it down just a little bit so I can go up and change the LFO frequency. I can go make it really fast, or I can make it really slow. I really want it to be about 3 cycles per second. I can actually just go in and type in 3 here. And so now the wave will do a complete cycle 3 times a second. Now that sounds pretty good. The one thing that I want to do with this is I actually want the first part of the waveform, that tine sound, I don't want it to trem, so I can actually delay the LFO a little bit. And what I'm going to do is I'm going to make the LFO start after about 0.3 seconds. So I think you can hear that it takes now about 1/3 of a second for the tremolo to start. Sounds pretty good. So the next thing I want to do is this voice basically always plays the same position in the stereo field. You can adjust the panning of a voice up here. If I click on the panning wheel and move it over all the way to the right, you hear that the voice is only on the right. And if I move it all the way over here, it's only on the left. Now that's kind of a brute force way to change panning. What I want to do is I want to make this patch so that high notes are more over in the right channel and low notes are more over in the left channel. So I'm going to set up another modulation routing and go here to the second set of chords, and I'm going to select key tilde, which is basically key up and down, and route that to amp pan, which controls the panning for the voice. And this is going to be sort of subtle, but as I change this up, you can hear that higher notes are more in the right channel and lower notes are more in the left channel. It's a little easier to see than hear, perhaps. If we look at the patch mix window and a low note, you'll see that there's more in the left channel, and on a high note, there's more in the right channel. See how the panning changes across the stereo field. That creates the effect of kind of sitting in front of a stereo instrument. Now, at this point, I've got a pretty good electric piano patch going. What I might want to do, though, is adjust one of the envelopes, and it's the amplitude envelope, and we can play around with, letting this sound ring a little bit more when we let up on the keys. So we go down here to the envelope section. This whole section controls each of the 3 envelopes that are active per voice. And the amp envelope by default, go back here, the amp envelope is routed to amp volume by default. And the point I wanted to make is that while there's not a patch cord set up for it, the amplitude envelope automatically controls the volume of a voice. So we can play with this a little bit. You'll see that right now the sound instantly comes on and then just about instantly comes off. There's a little bit of release time when we let up on the keys. If we wanted to change that, we could go in and we could actually adjust the envelope. If I adjust this parameter right here, this is the attack rate. If I were to say move this way up, you'll see that we don't hear any sound. I'm actually pushing keys right now. As I dial it down, we've created this effect where the sound kind of fades in. That's what an envelope does. Now we actually want the attack to be instantaneous, but maybe we want a little more release time. If I move the release parameter up, you can hear that the release time gets longer and longer, or we could make it really short. So that's kind of a funky effect, where the sound cuts off really quickly. What we want to do, though, is we want a little bit of release time. Now, one thing you might have noticed is that when we set the release time really high, so the release time here is 69 seconds, the sound should play for 69 seconds after we hit a key. But it didn't. And what's actually going on there is that Emulator X didn't do everything we need to do with the samples when it imported them into the preset. So I'm actually going to leave the voice processing window, and we're going to go look at our samples and see if we can figure out what's wrong. So I'm going to go over here to the tree view, open up the samples folder if it wasn't already open, and let's look at FME Piano C1. So we explored this a little bit before. You see that there's a very nice loop, but one thing that's not checked here is loop in release. The way this sample is set up right now, it will loop while a key is held down, but as soon as you let it go, then it just plays through the sample and doesn't keep looping. We want our samples to keep looping even when the key is up. So I'm going to go in for each of these samples, click Loop in Release. Okay, now when we go back to the voice processing window, we should hear really, really long release times. And yeah, that sound's just going to continue going for more than a minute. So I'll just move the release time back to a more normal value. Now, what do you do when you get a sound that's just going and going like that? You can actually go up to Options, do All Sound Off, and get rid of it. Okay, that's about what I want. Another thing that happens in real-world physical instruments is that a lot of times a higher note will die away a lot faster than a lower note. So I'm actually going to simulate that in this voice. I'm going to set the release velocity so that it's a little bit lower. Alright? And you can hear how it's set across the keyboard. And then what I'm going to do is I'm going to modulate that release time so that higher note values have a shorter release. Let's go in here to our second page of chords, and just like I set key tilde, that's the key up and down parameter, to control amp panning, I'm going to create a new chord that connects key up and down to amp envelope release. And let's listen to what this does. If I make a really high value, you can hear that on a high key, the sound now cuts off almost immediately when I let up the key, and then on a low value, low key, it'll ring out a lot longer. Now that's a little bit more extreme than we wanted, so I'm just going to scale this back. That's about what I want. Okay, so you hear that the lower keys ring out just a little bit longer. That's a really nice effect. Okay, one more thing we're going to do before we move on to the next layer. This sounds pretty good. Is I think I want to bring up a little bit more filter resonance. Bring out that tine sound just a bit more. There, that's very nice. I'm going to go back to the sampler window, and I want to show you something about stereo versus mono samples. When we originally created these samples, we recorded them in stereo, and so you'll see that each time they hit a key, down here in the number of samples playing window, it shows that there are 2 samples playing for every key. Why are there 2 samples playing? Well, Emulator X considers the left and the right channels separate samples. Now, in these particular samples, the left and the right channel are the same, so I'm basically wasting CPU cycles by leaving these as stereo. So let's go into the sample edit window and let's change all of these samples to mono, and this will make a much friendlier sample. I'm going to save my work real quick. Okay, now we'll click on each sample, and what you can see is, of course, there's 2 channels here. There's the left channel and there's the right channel. There's a processing option called Convert to Mono or Stereo. All I have to do is click this, and I get a window that lets me mix the samples into mono. And both channels are the same, so I'm actually just going to select 100% of the left channel. So I just move the slider all the way to the left and click OK. And now I've got a monophonic sample. I'll do that for each of the samples. And the last one. Now when we go back to the sampler view, we're going to watch the number of voices playing. And there's only 1 sample for every key. So we've actually made this a much higher polyphony sample or a preset rather, by turning our stereo samples into mono, and that works fine in this case. Now we're going to get started on the next layer of programming, which is the analog pad sound. So I'm going to save my work. And at this point, I'm ready to sample the other sound that's going to go into this preset, the pad sound we talked about earlier. As kind of a housekeeping measure, what I'm going to do is I'm actually going to turn off all of these voices, or all of these different presets around these different channels, because I don't want my MIDI keyboard to interfere with what we're going to do next. So you'll see that now we just have one sample active. If I change my MIDI keyboard to be transmitting on channel 2, we won't hear anything. And that's in fact what I want right now. I'm going to go and load up this other sound in my Nord modular keyboard, and here it is. This is a very, very big analog synthesizer sound. It's using a lot of pulse width modulation, and I'm going to make sure that my input levels are right. So I'm going to look at Patch Mix DSP. See if we're getting any clipping. Looks like a little bit too loud. I'm going to bring the volume down a little bit, so we don't want our samples to clip. There we go. Yikes. Okay, so now we're ready to sample this sound. I'm going to go back to Emulator X and once again go to File, Acquire Samples, and click the record button, and we'll just do some more sampling. So turn my mic down and I'll be right back. So once again, what I did was just sample C keys up and down the keyboard. I did a couple extra ones here than we did for the electric piano. Click OK, and you'll see that Emulator X has brought these samples into the Chop Samples window. And now we'll do the same trick as we did before. We will let Emulator X identify each of the samples. I'll adjust, there we go, adjust my threshold so that these will be properly identified. Let's click apply. Looks like we got it just fine. So here's the first sample. And just as I did before, I'm going to move the sample endpoints in a little bit so that the auto looping will work right. And I'm just going to move these in quite a bit. And move the last one in. Okay, now what we can do is we can do the same trick of setting the keys. I'm going to lock the start and end points. I'm going to hold down Shift and select all of my regions, and then I'm going to click Set Keys. And it looks like, once again, Emulator X correctly identified all of these samples except for the lowest and highest one. And so this is actually supposed to be sample C0, and this is sample C6. Alright, and then I'm going to Shift select all the regions again, set the names. Let's call this massive PWM for pulse width modulation. Include the original key name. Click OK. There are all my sounds. And now I'm ready to export these to the sampler. I'm going to once again create an entirely new preset, and we'll work on this new preset for a while, and then we'll copy the voices into the other preset. So once again, I want to normalize my samples, but this time, since these are truly stereo samples, there's different stuff going on in the left and right channels. I want to do relative normalization, and then I'm going to use half of the sample plus a crossfade for the auto looping, because I want there to be a really nice long loop where there's a lot of different sounds going on. And let's see, we'll call this massive PWM for the preset. Place the samples on the original keys, stretch them up and down, and put them into a multi-sample. Now click OK. And you'll see that Emulator X had a little bit more to work on there. We'll click Done. And now, when we're back in the sampler, you'll see that there's a new preset called Massive PWM. I'm going to save my work before we play with this. And now what I can do is I can actually take this preset, I'm going to drag it into the multi-setup window and put it on channel 2. So now I've got my MIDI keyboard set to MIDI channel 2, and we should be playing that sound. We're not hearing anything because I turned off the output. Click here, send its output to the main output. There we go. And so here's our new sound. Let's listen to the loop points. That all sounds pretty good. Now, what I'm going to do is let's go in and work on this voice. So I'm going to open up this preset. Let's go to the Voices and Zones window, and you'll see that once again Emulator X did everything right. It automatically set these different key zones that correspond to the different samples. I could actually double click here, go in and look at my samples. You can see that these are very complex waveforms with a lot of motion going on. And just like in the FM piano samples, I'm going to want these samples to loop and release. So as I go in and look at these, I'm just going to click the loop and release button. This will save us from having to do this later. There we go. Okay, so now I will go back to the Voices and Zones window for this new preset called Massive PWM. And let's go work on the voices. So I'll roll up the multi-sample, I'll select it, and then go to the voice processing window. Now this is a really rich voice. And so there's a lot of great stuff we can do with filtering. I'm going to go in and put the 6-pole low-pass filter onto this voice. And you can hear there's a lot of great stuff we could do with this. Let's set the filter about here for now. And then we're going to modulate the filter to do all sorts of cool things as we play. But this is a good starting place. And just like with the electric piano sample, you'll find that the high notes, they're being filtered just way too much. So I actually want to go in and do this mapping where we select key up and down and route that to filter frequency so that we let more frequencies in on the high side. Okay, that's about right. Now let's start programming a filter sweep. So there's a dedicated envelope for the filter control. If we go to the envelopes section of our window, you can click filter, and here's the envelope that's controlling the filter. You can see that there's a patch cord set up for it, filter envelope plus to filter frequency, meaning that as the filter envelope runs through its cycle, it's going to add its value to the current filter cutoff frequency. If I move this cord value up, you'll see that now the filter envelope is having an effect on the voice. If we made it negative, you would see that the filter envelope is actually subtracting from the filter frequency. Let's move this up so that we're getting some motion. And now we'll play with the values for the filter frequency. The filter frequency envelope. What we want to do is we want to create a nice ramp so that the filter sweeps after we hit a key. So I'm going to change the attack value. And you see we'll get that really nice filter sweep going. I'm going to set this up for maybe about 4 seconds. And you'll see that the filter sweeps up and then it stays at that very highest frequency. What we want it to do is kind of swoosh up and then swoosh back down. So what I'm going to do is I'm going to actually change the decay level, and you'll see what we're doing is we're kind of creating the standard attack, decay, sustain, release envelope that you commonly see in a synthesizer. Once I move this value up, let's move this to about 3 seconds. And you'll see the filter shoots up, reaches maximum value, and then sweeps back down a little bit. Let's have it go a little deeper. Okay, that's pretty cool. Now, the other thing you might remember from the finished sound is that this sound actually faded in. So we're going to go to the amplitude envelope, and let's make the attack time a little slower. And then let's also go in and change the release time so that it rings out a little bit longer. Now, one thing you can hear going on is that even though the amplitude decays for a long time, the filter closes back down. It goes as soon as we release the keys. We don't quite want that, so let's go back to the filter envelope and let's change its release time to kind of match the amplitude envelope. So the amplitude envelope has a release time of 3.3 seconds. Let's change this one to maybe roughly double that. And that's a really nice kind of ringy tone that we're getting there. Now, to kind of jazz things up a little bit, let's have the pitch change over time. And we're going to use one of the LFOs to modulate the pitch. By default, there's already a patch cord set up for this, and that's LFO 1 up and down to pitch. And if we play with this, you'll see that we can get really extreme pitch sweeps. Now, that's maybe a little bit more than what we want. And in fact, we might not even be able to get exactly what we want. Well, that's about right. But you can see that I don't have a lot of control over it. If we set this to say 10, there's still going to be too much pitch modulation. Yeah, that's just too crazy. So there's actually a different parameter we can control. There's a parameter called fine pitch, which is just like pitch, except it's a little more tightly constrained. And that's nice. That's a little bit lower. We want to make the frequency kind of slow. What we're going to do is just set it so that it takes a long time to cycle through that. Okay, that sounds pretty good. The next thing I'm going to do is I'm going to use that same LFO to modulate the panning of this voice, just to give a little stereo motion. So we'll make a new patch chord. We'll go LFO1 up and down to amp pan. Where are you? There you are. Amp pan, and we'll just do this about like that. And there's some nice stereo motion now across the stereo field. And this is probably another good point where we should save our work. So I'll hit save. So one other thing I want to do with this patch, I want to give it a little bit more filter motion. So just like I took LFO1 and routed it to panning, let's take LFO1, and there's LFO1 up and down. Let's route that to the filter frequency and just give it a little bit of up and down. We don't want a real wide sweep like that. We just want a little bit of extra filter motion. Okay, that sounds pretty good. Now at this point, I think we're ready to start working on the electric piano patch again and actually combine the voice we just worked on here with the electric piano. So what I'm going to do is go to the Voice and Zones window for Massive PWM, and in the Voices and Zones window I'm going to right click on this multisample and copy it to the clipboard, and then I'm going to go into the Voices and Zones window for the other preset, and I'm actually going to paste. And the paste dialog lets me paste after the end of the current selection. And there's my new multisample. Now, if we go back to the sampler, what we should have is, I'll change my MIDI channel here. We should have, yep. There we go. We've got a preset now that has both of these voices in it. So that actually sounds pretty cool. There's a couple things I want to change first off though. Let's go here into the Voices and Zones window. And I'm actually going to select the Mix/Tune window. This is where we can do things like set the relative volume of different voices as well as the panning on a global basis. One thing I noticed is that I think that the analog synth sound is a little bit loud with respect to the electric piano, so I'm just going to back this off by about 8. Alright, that sounds a little bit better to me. And then the other thing I wanted to show you in this window is the group function. Sample groups or voice groups are a great way to keep track of different voices in a complex sample. And basically it's a way of saying, hey, I want to edit all of these voices at the same time. You'll see that by default both of these voices are in group 1. I'm actually going to take voice 2 and put it in its own group. So I've got group 1, which is the electric piano multisample, and group 2 is now the analog synth multisample. Then if we're in the voice processing window, I can go up to the voice selector and I can actually change the groups. So in group 1 I'm working on voice 1, in group 2 I'm working on voice 2. So this is an easy way to keep track of what I'm doing. The other thing you could do is you could select all groups, and now any change that you made to any parameter here in this window would actually be applied to both voices. I don't want to do that right now, but I'm just showing that we could. So let's go back to group 2, which is our analog synth sound, and let's make some more changes. So now that we're back in the voice processing window for voice 2, there is a couple of things that I would like to work on. In the context of this patch, and now that both sounds are together, there's a couple things I do want to change. One is I want to make this voice a little more responsive to velocity, and I'm going to just hook up the velocity scale parameter to filter frequency here, so that as we press harder, the filter opens up a little bit more. So we're going to do that. Also, it feels to me like the release time on the amp in this voice is a little bit too long. That's a little bit better. And so now let's go and set up some different effects. The first thing that I want to do is let's set up the vibrato for this patch. Vibrato is typically the kind of effect that you have brought in by the modulation wheel. And so you'll see that there's a chord that Emulator X automatically hooks up for us that takes the modulation wheel and connects it to this destination called chord 03 amount. Now what does that mean? What that means is that as we move the modulation wheel up, it's going to add some value to the current value of chord 3. And so we look up here, and here's chord 3, where I have LFO 1 controlling fine pitch. So let's just see if we can hear anything going on. It doesn't really seem to be doing much because the value is so small, but if I change this value, see, now you can hear that there's a lot more vibrato now. But we've already really been using LFO1 for the amp panning and for the filter modulation. So what we probably want to do is a couple of things. One, let's use LFO2 to be modulating the pitch, because I want to just decouple these effects a little bit. So now we'll look at LFO2. And with the mod wheel all the way up, you can hear that there's quite a bit of vibrato. It's maybe a little too fast. I want to move this down to about 2 cycles. Actually, I want it even slower than that. I want that kind of Vangelis vibrato. Yeah, that's more what I want. Okay, that's pretty good. I'm also going to scale this down so it's not affecting the pitch quite so much all the time. Now let's go and so one thing we can do is we can even experiment with the shape of this LFO a little bit. Let's try setting LFO2 here to be a sine wave. Let's just hear if that makes any difference. That's a little bit more, I think, the sound we want. I'm also hearing a little popping noise, and I think that that is a bad loop point in one of the electric piano samples. We'll fix that later. So let's see. So far, we've got our sound coming along pretty well. There's another couple things I want to do. Let's go into the second set of patch chords here. I'm hearing a little bit too much swooping on the filter frequency in that pad, so I'm just going to scale this back to about 8. I want this to be more subtle. Yeah, that's a little bit better. And now let's set up this special effect. You'll remember in the finished sound there was an effect where I hit a switch and the sound of the analog synth went up an octave. Here's how I did that. There is a modulation source called thumb switch FF, and the FF stands for flip-flop. This is a modulation source that toggles between 0 and 1. You can also set it up on a foot switch. I happen to have a controller that has the special thumb switch, so I'm going to use thumb switch, but you could just as easily use foot switch 1 FF or foot switch 2 FF. So I'm going to select thumb switch FF, and we're going to route that to pitch just to show you what happens. So thumb switch FF to pitch, and I'll just put this all the way to 100%. And when I hit the thumb switch, you hear the sound jumps way, way up. Now, we don't want it to jump up that high. We actually just want it to jump up an octave. And it just so happens that if you set the pitch amount to 38%, that's an octave. So now we can try it, play some keys, and hit the thumb switch. And you'll hear that the pitch changes by an octave. Now that's not exactly the same effect that we had before. The pitch before kind of swept up. So we're going to make this a little more sophisticated. Instead of routing the thumb switch directly to pitch, what I'm going to do is I'm going to route the thumb switch to one of the lag processors. So I'm going to select lag 1. And I'm going to set the value to 100%. What the lag processors are these special modifiers that take a signal and they kind of smooth it out. And so the lags are controlled right here. There's 2 of them per voice. There's lag 1 and lag 2. So if I set the thumb switch going into lag 1 and set the value to 100%, what's going to happen is lag 1 is going to smooth out that switching, and it's going to create this smooth ramp that goes from 0 to 100. And then I can set up a second chord that takes the output of lag 1, and that is this source right here, lag 1, and route that to the pitch. And you'll see that if I set this value to 38 now, it's a little bit smoothed out, but you see that we have the lag processor set really slow. Let's change the rate up a little bit, and then you can really hear, and then we'll fine-tune it. So there you go. The thumb switch is going into lag 1, and then lag 1 controls the pitch. Let's make it a little bit faster. Let's maybe set this value at 4. Hear how that sounds. That's a nice effect. We'll just leave that just like it is. And another thing I want to do for this voice is let's make it so that the player can control the filter cutoff and resonance in real time. Another one of the modulation sources that we have are MIDI A through MIDI P. These are continuous controllers, okay? And these can be knobs or sliders that are on a MIDI controller that you might have. And any of these can be hooked up to connect any of the modulation destinations. Let's hook up MIDI A, and we want MIDI A to control filter frequency. So I will go and select MIDI A to filter frequency. And there are two options. Of course, we could make MIDI A add to the filter frequency or make MIDI A subtract from the filter frequency. Let's make it initially add to the filter frequency. So we'll pick a value, and then now you see as I move MIDI A controller, the filter frequency goes up and down. Let me show you where that's happening. If you click on the name of a preset, you go to the preset global window. We'll come back here in a second, but let's click on the sampler right up here, Emulator X. That shows us the multi-setup window. Whatever of the presets you've clicked here, you will be shown the value of the current continuous controllers down here. Okay, so here's controller A, and watch as I play, we see the value changing in real time. One really cool thing that we can do is we can label these controllers down here, and you do that in the preset window. So I can go here to controller A and I can give it a label. I can say this is filter frequency. I can also set an initial value for this controller. There's one problem that you might have noticed. There's only so much that we can change the filter frequency. We can just add to it, but we're not really able to close the filter down all the way. So we might want to change the way we've done the programming. I'm going to go back to the voice processing window, make sure I'm in voice 2, and what I'm going to do is I'm actually going to close the filter all the way down for all voices. Okay? So you hear that hardly anything will come through. And then what I can do is I can set MIDI A to control filter frequency 100%. Now, the player has complete control over filter frequency, but I really don't want my preset to start out like this, with the filter closed all the way down, or with the filter open all the way up. I want it somewhere in between. Kind of about here. So what I can do is I can actually go back to the sampler, and I can see that the current filter frequency amount in controlled by MIDI controller A is about 46. So then what I do is I go to the preset global window, and I can set an initial value for controller A. Let's set it at 46. 46. I'll type it in. Okay, so now when this patch is this preset or this patch is initially loaded, controller A will initially start at the value 46 and will give us the sound that we want. I'm going to go back into the voice processing window, and I'm going to do a similar thing for MIDI controller B, except with MIDI controller B I want to control the filter resonance. So let's go in, we'll select MIDI controller B, map it to filter resonance. Now there are actually two types of filter resonance. There's this one, apostrophe filter resonance, and then real-time resonance. Apostrophe filter resonance is sort of a historical control, or a historical destination for modulation routings. In the E4 series of samplers, like the E4XT, the E4K, the filter resonance could only be modulated when a note first starts. So you couldn't adjust the resonance in real time while a note was playing. Emulator X adds the capability of being able to tweak the resonance in real time, and so that's what real-time resonance is, and I'm just going to select that. So now MIDI controller B is set to control real-time resonance. I'm going to set its value to 100%. I'm going to take the default resonance and move it down to 0%. And then we're going to find the right setting for MIDI controller B. So there's full resonance. I'm going to move MIDI controller B back. There's no resonance. I want it slightly resonant. So that sounds like a good setting. Let's go back to the sampler. We see that controller B is at 56. So then I will go to the preset global window. I'll label controller B as filter resonance, and I'll set its initial value to, what did I want? 56. There we go. So now I've set defaults for the filter frequency and resonance, but you can change them with MIDI controllers A and B. So once again, I'll go back to my sampler window. Oops, there's the sampler window. And we can watch them change in real time. See that filter resonance is going up and down. And filter frequency going up and down. Okay. So with that, let's go and do a little bit more work on voice 1. So remember that we assigned voice 1 to group 1. I can select group 1, and now from the voice processing page, I'm only working on voice 1. What I want to do is I want to set up the vibrato for this part of the preset. You can see that once again, LFO up and down is being routed to pitch, and then the mod wheel is being routed to control the amount of LFO1 to pitch. So this gives us vibrato on the mod wheel. Let's just turn the mod wheel up way up here just to hear what this sounds like. Okay, that's kind of a lot more than what we want. So let's go in and make some changes. First, I want this LFO to be similar to the one that we're using for the tremolo effect, the LFO1 to amp volume. So what I'm going to do is I'm going to make one similar but slightly different. Let's, instead of using LFO1, let's use LFO2 to control pitch. And so I'll select LFO2, and let's make it very similar, but we'll make it like 2 cycles per second. So just change it there. Let's also make it a sine wave rather than a triangle wave. Let's hear what that sounds like. So that's about right if we got the modulation amount right. Let's just have, let's see if just going up to about 12. That's still more than I want. I just want a very subtle pitch change. I'm going to change this to fine pitch so I have even more control. That's good. Now, just like I did, you'll remember back when I was setting up the tremolo, I made it so LFO1 has a delay on it. Let's do the same thing with LFO2 so that it doesn't come in immediately, but it waits 0.3 seconds. And that'll let that tine sound come through without it going wow, wow, wow. Okay, that sounds pretty good. Now with that done, what I want to do is I want to set up a continuous controller that lets me crossfade between these two voices so that I can actually have a controller that lets me play just the piano sound and then just the pad sound underneath it. So what I'm going to do is I'm going to go back up to the Voices and Zones window, and I'm going to look at the RT Win window. RT window is the real-time window, and the real-time stands for real-time crossfade. And what this allows me to do is set up a controller that in real time can switch between voices. So let's take a look at how this works. Here are my two voices. This is the electric piano. This is that analog synth sound. And what I can do is I can set up a range for the real-time controller from low to high where the sound's going to operate. And so what I'm going to do is I'm going to take the electric piano sound and I'm going to make it so that it operates between 0 and let's say 100. Okay? And then I'm going to set up the synth sound so that it's only available from value 27 or so up through 100. So you'll see that there's a place where there's absolutely no synth, and then there's a place where there's absolutely no electric piano. And then I'm going to set up a fade. So I'll make it so that, let's see, we'll set this to about 30. Set this into about 30 as well. We're making it so that there's just a small zone where both samples are playing at the same time, and then you eventually get to a point where it's only one or the other. Okay, so this is the range where both samples will play together, both voices will play together, and this is the zone where it's only electric piano, and this is the zone where it's only the synthesizer sound. Now, how do we actually get this to work? What we do now is we're going to go and we're going to select both voices. So we're going to edit both of them at the same time, and we're going to go to the voice processing window. Now you'll see that we have both voices selected. This is just like if I selected group all. Okay? And what we want to do is set up a new patch chord, and we'll set it up down here in some of these unused spaces. Keep in mind we're editing both voices at the same time. So if we change one of these chords here, we're going to change both sounds. We don't want to do that. We want to make sure we're in an area where we haven't used any controllers yet. And what I'm going to do is I'm going to pick the continuous controller that I want to be responsible for that crossfade. I'm going to pick MIDI controller D. And the destination that we want is real-time crossfade. And that is it's actually called amp crossfade, and it's right here. And then what we do is set its chord amount to 100%. And then what you'll see is that MIDI D is going to control this crossfade. Let's go back to the sampler window. Sorry. Make sure that we're looking at the preset that we're actually playing. And you'll see that controller D is currently 0. As we move it all the way up here to 127, we get only the analog synth sound. Then back here at 0, we get only the electric piano sound. So what I want to do is I want this patch to start at a value right in the middle, about 64, so we hear both of them. That's good. So remember, the way we set that up is we go back to the preset global window. Oops, sorry. Preset global window. And for controller D, let's give it a label. We'll call this real-time crossfade, so we know what it does. And we'll set its initial amount to 64. And then whenever this patch is loaded, we'll be right in the middle zone where both of the sounds play, but the player can change it later by tweaking controller D. Another thing that you should be aware of is that even if you don't have an external controller with like knobs or sliders on it, you can always just touch the controller on screen and get the same effect. So we'll fade just up into the synthesizer area, and then we can fade just into the electric piano area. Okay, with that done, there's one other controller I wanted to set up. I wanted to make it so that the player can control how long it takes for the synthesizer sound to decay. So I want them to be able to change the envelope release time. What I'm going to do is go back to the voice processing window, select group 2, which is just the analog synth sound, and you'll see that here's space, right, for a new controller. And so what I'm going to do is I'm going to connect MIDI controller C to a parameter called amplitude envelope release, and I'm going to make it so that you can make the release times longer. So let's just put this up at maybe about 30%. I'll just type it in. And now MIDI controller C changes the release time. So here it is at its low value, and then if I move controller C up to 100%, you'll see that it gets shorter. So higher values make the amplitude envelope release time shorter. I actually want the opposite behavior. So I'm going to change this to -30. So that moving MIDI controller C will make the release time longer. So here's MIDI controller C at 0, and then we'll put it up to 100%. And you see we get this very long release time. So now that I have that kind of control, I think what I'll do is I'll make the default so that the release time isn't so long. So what I'm going to do is I'm just going to move. So here we are on the amplitude envelope. I'm going to move its release time to be a little bit less. We'll say start it at about ½ a second, and then we'll let MIDI controller C control how long it goes. So since we know what that does, let's go back to the preset global window. I'll put a label here, say controller C is for synth release, and let's set its initial value to 0. And I'm going to go back into the multi-setup window. You can see that now I've got all 4 of these labels defined. And the synth release time goes from short to very long, depending upon where MIDI controller C is. Okay, that all sounds really good. So with that, we're more or less done with this patch, except that we're not using any of the effects. And so the final step that I want to do here is I want to take advantage of some of the effects that are provided by the eDSP card. Let's just go and look at the PatchMix DSP window. So you'll see that there are essentially 3 buses defined for Emulator X. There's EX main. This is where all the voices are going right now. But then there are 3 other buses set up. One that's labeled reverb, and this channel has an insert where there's a reverb effect. There's another channel called delay that has an insert of a delay effect, and then there's a third auxiliary send here that's called distort, and it has a distortion effect set up. So how do we take advantage of these effects? Well, I'm going to go back to the multi-setup window, and the first thing I need to do is I'm going to take the patch that I'm playing and I'm going to click the aux button. This enables the auxiliary sends. The second thing I'm going to do is actually make sure that I have the auxiliary outputs set up to go to the different mixer channels. When we did file new, that actually reset Emulator X so that there's no auxiliary outputs defined. What I want to do is take auxiliary output 1 and I'm going to route it to reverb. I'm going to take auxiliary output 2 and route it to the delay. Now we can have our preset take advantage of these auxiliary outputs. So how do I do that? First, I'm going to go back to the Voices and Zones window, and let's just make sure we're working on voice 1. So this is the electric piano sound. let's take this sound and let's send some of its output to the different effects buses. Here in the amplifier section of the voice, you'll see that there are these little pots that control the output to the different buses. So right now we're sending all of this voice to the main bus and none of it to aux1. Remember that aux1 is routed to reverb, and we're sending none to aux2, which is routed to delay. So what we can do is let's route a little bit of this patch, or actually maybe a moderate amount of it, say 40% we'll route to reverb, and then let's route about 50% to delay. And now what you'll hear, and actually what you'll see when I bring eDSP back up, hear how we're getting the delay effect? Okay, and we're also getting the reverb. Now the reverb isn't very noticeable right now. I'm going to bring up the patch mix DSP window and let's edit the reverb. For a patch like this, we maybe want a really long kind of hall reverb effect. So I had already selected the large hall preset, but we can enhance this a bit. Let's make it a little bit more wet, and maybe let's even bring the decay time up a little bit and hear the effect of that. And of course you can see that now there's signal that's being sent to the reverb bus as well as being sent to the delay bus. So let's do a similar thing for our pad sound, the synth sound that's underneath these. I'm going to change that a little bit though. I'm not going to send as much to delay, and I'm going to send more to reverb. So I can select group 2, which again is that synthesizer sound, and I will send it a lot of signal to the reverb bus and just a little bit to the delay. Let's hear how that sounds. So you can see that that adds a lot of character to this sound. And with that, we've pretty much got a finished sound. Now, one kind of bonus thing here is let's take a look at what's causing this popping noise. I think that there's a bad loop in one of the piano samples. If we listen to this key, and actually it'll help if we turn the effects off. Let's go in and let's just turn off the auxiliary routing for a second. Yeah, there it is. It's kind of in this middle range. I'm hearing a little bit of a popping. So let's go in and examine. It might be this sample. Actually, it's maybe the one a little bit higher. Let's check the one lower first. That sounds pretty good. Maybe it's this one on C5. Yeah, hear that little tick? Whenever it loops, there's a little bit of a ticking sound. So that's causing this. So let's try to fix this popping sound in EPC5. What I'm going to do is first save my work so far. And then what we'll try to do is let's just adjust the loop points and re-crossfade this loop. So what I'm going to do is I'm going to move the sample start point in and also move the end point in to where it looks like we've got a pretty consistent kind of loop. Now you hear this big pop. That's because the sample start and sample loop end are not really in alignment. There's a function that's built in to the sample loop menu called autocorrelate loop. And what autocorrelate loop does is it tries to match the start and end points of the loop so that they're at so that the waveform is going the same way. So I'm going to click that, and you'll see that moves the start point out to a place that matches the end point. See, that's a lot smoother. See, there's no popping anymore. So now what I can do is go to Sample Edit, Loop Processing, and what I'm going to do is I'm going to re-crossfade this loop. So I can just select a crossfade length here, and what this is letting me do is actually letting me take samples from here and samples from here and mix them together, kind of smooth out this loop point. Now let's try this first. Well, that sounds pretty good. We basically got rid of that pop. So let's save our work. Go back into the sampler, turn the aux bus back on, and this should be our finished sound. So I hope that you enjoyed taking a look at how you can build a great sounding preset from scratch. You can apply the ideas that you learned in this lesson to just about any of your synthesizer programming, especially with Emulator X. And hopefully by following along with this example, looking at some of the presets that ship with Emulator X, you'll be able to create great new patches.